Yes. First one's pretty straightforward. If you try multiplying by 2, 3, 4, 5, and then you see right away 3 times 7 is 21, and 21 mod 10 is 1. So you multiply by 3 both sides. And this is 1, and 3 times 3 is 9. That's easy. Now, as the second question, a number x has the following property. If you multiply by 3, the last digit becomes 7. Okay? Find the smallest two-digit number that satisfies the above. Well, for any number, whatever you do, any number, the last digit is what you get if you divide by 10, right? If you do this number, mod 10, you get the last digit, right? So whenever you see a question that has the last digit, you should always think about mod 10. Therefore, the equation is really saying the following. X is a number if you multiply by 3 and you do mod 10, you get 7. You're looking for numbers that satisfy this. That's the smallest two-digit number. So first of all, you should multiply by 7 because in the previous question we observed that 3 times 7 is 1, right, in mod 10. 3 times 7 is 1 in mod 10. So if I multiply 7 both sides, then that's going to make this as 1. And x is congruent to 49 mod 10. Well, wait, 49 mod 10, what's that? 49 mod 10 is?
1.
No,
Would be 9.
9, right? So you see that this is also saying that x is congruent to 9 as well. Okay, so remember, when two things are congruent, mod 10 means that if you divide x by 10 and get a remainder, if you divide 49 by 10, get a remainder, those two remainders are the same. And because this one has remainder of 9 after dividing by 10, that means x is congruent to 9 as well. Is that good? Yeah. All right. So let's try to think about all the possible numbers that this is true. What is that? X is 9, 19, 29, 39, also negative 1, negative 11. These are all congruent to 9 mod 10, right? But among them, the smallest two-digit number is 19, okay? So that's the answer. Uh, 3, 9, 12, these are all divisible by 3, therefore we can divide both sides by 3. Remember, when this number is divisible by 3 as well, you have to divide this by 3 as well in order to get a correct answer. And that gives you x is congruent to 3 mod 4. Now, what does that mean? That means x is equal to 4k plus 3, right? 4 times some number plus 3. That's what x looks like. Okay? But see that the question is asking us to get the x as mod 12, right? So we need to somehow convert this into 12 times something plus something. And we're really looking for that. Okay. One way to get the answer is just by listing every number. So if k is 0, you get 3. And then k is 1, 4 plus 3 is 7. If k is 2, 2 times 4 is 8, 8 plus 3 is 11. And it's moving up by 4, right? So the next number is 15. And then 19, add 4 to 19, you get 23. Just like that. And you can see that because the difference between 3 and 15 is 12, and 7 and 19 is 12, and 11 and 23 is 12, mod 12, the subsequent numbers are the same as the ones before, right? See, these two are congruent to each other because they're 12 apart. Any two numbers that are some multiples of 12 apart will be congruent in mod 12 system, right? Yeah. So that means this is one way to view that the correct solution of this is x is congruent to 3, 7, or 11 mod 12. Okay, so that's one way to view what's going on. Slightly more technical but more rigorous way of seeing this is to do the following. I want 12. So 4 times what gives me 12? 3. So you want to rewrite k as 3 times t plus something, right? But see, we don't know what k is. K could be any integer. And if you have 3t, what's the possible values for r? If it's 3t, what are the possible remainders that you can have if you have any integer? First, it could be divisible by 3, in which case r will be 0, okay? Or it could be, the remainder could be, you give me any number k, then I can always write it as 3t plus some number, where this remainder is 0 or 1 or 2, and that's it, right? It's one of those three cases. There can't be anything else. Any number can be either 3t plus 0, or 3t plus 1, or 3t plus 2, right? So if you know that, then just think about what that means for x. If k is 3t, then that's 4 times 3t plus 3, which means 12t plus 3. And if x is 12t plus 3, that means x is congruent to 3 mod 12. Agreed? Right? If you divide by 12, the remainder is 3. That's what it means. Okay? If k is 3t plus 1, then what is x? X is 4 times 3t plus 1 plus 3. And if you multiply this out, that's x equals to 4 times 3, which is 12t. 4 times 1 plus 3, that's plus 7. And that means x is congruent to 7 mod 12. And this last case, when x is congruent to, that means x is equal to 4 times 3t plus 2 plus 3, and that means x is equal to 12t plus 8 plus 3, which is 12t plus 11. Okay, so that means x is congruent to 11 mod 12. Okay? So this way, you've basically proved that there are only 3 possible solutions to this equation. So the solution of this is that x is either 3, 7, or 11 mod 12.